Good morning, guys. So my name is Bill Seliman Okwame, a student of the Mathematics Department, University of Ghana, popularly known as UGen. Okay. So in this video, I'll be explaining normal distribution. Then I'll solve a question for you to apply when we are talking about normal distribution, okay? But before I begin solving the question with you, I want to give you the understanding about normal distribution, what normal distribution is about. Then we can start. So on our screen here, when we say normal distribution, we have this is a normal distribution graph that I'm drawing. So let's say we have our normal distribution. So changing the color. So, okay. So whenever we are doing a normal distribution, there are two things they will give you in the question. The first thing is your mean. So they will give you your mean. Then the second thing that they are going to give you is your standard deviation. This will be your standard deviation. So what are we going to use the mean and standard deviation for? Right? That is the question that we might ask ourselves. So the mean and standard deviation, this is what we are going to use it for. For the mean, always remember that a normal distribution graph is symmetric. So what does it mean to say something is symmetric? It means that we can divide that thing into two equal parts. Do you get it? So we can divide it into two equal parts. And the division is being done by the mean. So you can see that when we divide this into two equal parts, so if I divide this into two equal parts, then the mean is the one that is dividing or causing the symmetry, dividing the graph into two equal parts. Then what do we then use the standard deviation for? You might be wondering. Then the standard deviation is how much the values deviate from the mean. Do you get it? So when we move on to the right side of the graph, then it is one times the standard deviation. They get it. It means that the right side of the graph is we adding the standard deviation to the mean. So when we come here, let me use broken lines. When we come here, it is just one times the standard deviation, one times the standard deviation. So theta, one times the standard deviation. What does it mean? If I'm saying one times the standard deviation, If I'm saying one times the standard deviation, then it means that if I was, if, then it means that if let's say our mean is 8, let's say our mean is 8, then our standard deviation, let's say our standard deviation is 4, okay? Then the value that will be recorded here will be what? 4 plus the 8, and that value is going to be what? 12. Do you understand what I'm saying? Good. So whenever we are drawing the diagram, then we can see that whenever our mean is given to us on the right side, we just keep on adding the standard deviation to the mean. So the second one is going to be 2 times the standard deviation. They get it. 2 times what do I mean by 2 times the standard deviation? 2 times the standard deviation is going to be Now, our standard deviation is 4, right? So we are going to add 4 plus the 12 here. 4 plus 12 is going to give us what? 16, right? Meaning our next value here is going to be 16. So on the right hand side, we just keep on adding the standard deviation. So 2 theta. So Okay, let me do some quick correction over here. When I say 1 theta, doesn't mean that 1 times the standard deviation. It is just a numerical representation. I just want to tell you that the first theta, the second standard deviation, the third standard deviation, that is what I mean. Okay, it's not that you're multiplying 2 times the standard deviation. Somebody might think that if it is 2 times the standard deviation, then here it's supposed to be 8, not 16. That is not what I mean, okay? So that is a quick correction that I want you to have, right? So when I say 1 theta, 2 theta, they are just representations that I want you to understand. But the actual thing is that when we are moving to the right side of the standard deviation, the values keep on increasing. How do they keep on increasing? They increase by the standard deviation. So if I'm having my mean 8 and my standard deviation is 4, so as I move on to the first on the line, first to the right of the mean, it is going to be 4 plus the 8, which is what? 12. When we keep on moving, we keep on adding a standard deviation, which is what? 4 plus 12, which is 16. Then I believe you can guess the next value, right? The next value is going to be 16 plus what? 16 plus 4. And that is going to give us what? 20. Do you see that? So that will be our third value recorded here, right? And that third value is 3 theta. And the value itself, based on the standard deviation that I'm using, is going to be what? 20. Do you get it? But when we go to the right-hand side, what is happening? The right-hand side, let me use a different marker. For the right-hand side, a different thing is happening, right? Instead of the values we thinking that the values will increase on the normal line, you can see that the left hand side decreases. The values will now be decreasing. Do you get it? But they decrease by 4. They decrease by 4. So it means that our recorded value here, if the mean is 8, then the standard deviation is 4. We're just going to be reducing the mean by 4, meaning 8 minus 4. Our first recorded value here is going to be what? Is going to be 4. Do you get it? If we move next, if we are moving, the next recorded value is going to be 4 minus 4. We are reducing it by the standard deviation. That becomes what? 0. Then our next value becomes what? 0 minus 4, right? 0 minus 4. And that becomes what? A negative 4. I hope it is clear. Good. So all these values is what? The values that we can record. If, for example, our standard deviation was given to us 4 and our mean was to be 8. I hope it is clear. Our mean was to be 8. So our mean was to be 8. Okay, so there you have it. Now, what do I want you to understand when it comes to this also? What I want you to understand is this. Because the normal distribution curve is symmetric, right? What it means is the distance from here to here is the same distance from here to here. You get it? So the distance from 4 to 12, from 8, the mean to the first value to the right, to your right, is the same as the distance from your mean to the left value on your left. Do you get it? So it means that from here to here too, from here to here is the same when we start from here to up to here. The distance from here to here is the same as the distance from here up towards here. Do you get it? Let me use a different color. Let me use a different color for that. So let's use black. So it's the same as the distance from here up towards here. But there's one thing that I want you to note. Then we'll go to our GeoGebra, right? So everything that is happening here, we call it area under the curve. And the area under the curve is what gives us what? The probability. Do you get it? The area under the curve is what is giving us the probability. So then let's go to our GeoGebra, okay? So this interface is our GeoGebra. And when we want to use the normal distribution, we just have to come to the small arrow here. We tap on it, then we look for probability. Do you get it? We look for probability. So there we have it. So here we have normal distribution. We can change it to others, but we want normal distribution. And this on this calculator, right? Uh, Mean, sorry, our mean, right? And this time is called mu. Our mean is 0 and our standard deviation is what? 1, right? Like I explained in the video, when we are moving to the left, it is increasing, right? So you can see that 0 and it is increasing by the standard deviation. So 0 move on to 1, 1 plus another 1 giving us 2, 2 plus 1 giving us 3. But when we move on to the left, it is decreasing by the standard deviation, right? So 0 with minus 1, right, gives us a negative 1. Negative 1 minus 1 gives us a negative 2. Negative 2 minus 1 gives us what? A negative 3. So it is decreasing by the standard deviation to negative infinity, and the right-hand side is increasing toward positive infinity. I hope it is clear. Good. So always remember that the distance or the area under the curve from the the immediate standard deviation. You see that from 0 we'll move on towards 1. From 0 we'll move on to negative 1. The area between it will always and forever be 0.6827. Do you get it? Regardless of how much we are changing it. So what do I mean? Let me go to the board to explain something to you. What I mean is that whenever we are having a standard deviation, a normal curve like this, so whenever we are having a normal curve, so this, let's say this is our normal curve, good. Then we have our first value recorded. This is our first standard deviation. Our first standard deviation. It doesn't matter what value is there, okay? And this is our second standard, also our first standard deviation. But let's denote it by a negative, okay? Then between it, is the mean, right? So what I mean to say that the area under the curve from the first one to the left, immediate first to your left and immediate first to your right, the area under the curve, as I said, the area under the curve is also called the probability. So the area, these regions, the regions that I'm crossing, right, they will forever and ever, right? So thy kingdom come, just a joke, be the same or will be equal to, not be the same, but they will be equal to what? That area there will be equal to 0.68, sorry, will be, let me clean, will be 0.682 and 7. Okay, so when we change this to percentage, then it's going to be 68.27. So always the distance from the immediate first to the immediate second is going to be what? 0.6827. That will be the probability, regardless of the value here. That is to say that even if I come to this diagram and they ask me that what is the area within the interval 4, within the interval 4 and 12. Do you get it? 4 and 12. Within the interval, they ask me that what is the area? You can see that 4 is the immediate left and 12 is the immediate right. They are all the first. So always remember that the area under the curve, when we are talking about the first ones, that deviates from the mean, the first one, the first values, it is going to be what? 0.6827. Do you get it? It doesn't matter the values that are here. The concept is the first values will give us what? 0.6827. Do you get it? And we have values when we come here, meaning we can change it. You can see that from -2 and +2 will be the two next immediate values, right? So the area from the second values, what is it going to give us? When we come here, let me explain the interface to you. So this means that the probability between, right, between two values, right? So all that we have to do is to just key in -2. Then when we come here, we key in what? 2. Do you get it? So then we press enter. So it means that the probability from the next two values from one value, they meet values away from the standard, sorry, away from the mean, two steps to the left and away from the mean, two steps to your right. The distance or the region under the curve will forever and ever be what? 0.9545. What do I mean by that? If I'm to come to my diagram, you see that the values here are even different, right? But it doesn't matter. All the concept that I want you to grasp is that whenever you are doing any normal distribution, then always remember that the distance from the second, two steps, let's move two steps, one, two. So this is the steps that we are talking about, right? Now let's move two steps again, one, two. Do you get it? This is the two steps. So the distance or the region under the curve, two steps, when we shade all this region, right? Let's keep on shading. When we shade all these regions, do you get it? When we shade all these regions, what are we going to get? The probability of getting a number between the 0 and 16. So 0, 0, and 16 will forever and ever, because they are both two steps away, it is going to be what? 0 point, as we saw on the screen, 0.95. Then let's go to this. So 0.9545, right? Then 45. When we change this to percentage, then it means we are just to multiply by 100, and that is going to give us 95.45. I hope it is clear. Now that we have the understanding, let's apply it in a question. I hope it is clear. Good. So now let's come to our question. This is our question, the question that I want us to solve. So when you look at this question, the question says that the test scores of physics class with 800 students are distributed normally with a mean. So you can see that the question gave us a mean and the question gave us a standard deviation. And these two values, they will be given to you in the question whenever you are solving a normal distribution question, right? So we know that the total number of students is 800 and the mean is what? 75, and the standard deviation is what? 7. Do you get it? Let's go to our board, then we'll draw the normal distribution. Then we do the graphical one using the app that I'm using, okay? So let's say that you want to solve this question using pen and paper. How are you going to solve it? It is easy, right? So let's go to our board. If we come to our board, let me open another, board. Okay, let's see it. Okay, okay. What is it? Okay, we can't even use it. Let's scroll up. Okay, okay, there's it. Let's scroll up, up. Okay, up. Good. So let's begin. So remember that how many students, if you saw the question, how many students were the 800 students, right? So let's write the informations that we need. We know that The population is 800. And always remember that in normal distribution, the standard deviation is that of the population. You know that we have two types of standard deviation, one for population and one for sample, right? But whenever we are talking about standard deviation, the standard deviation should always, whenever we are talking about, sorry, the normal distribution, your standard deviation you should keep in mind is that of the population, all right? So we know that the population P, the total number of people is equal to what? 800. Good. Now, the next thing that we they give us in the question was the mean. And they told us that the mean is equal to what? Is equal to 75, right? We write that down to is equal to 75. Then the next thing that they told us was that the standard deviation was what? Was 7. Do you get it? So the standard deviation, this time I wrote it here. Let me, okay, come on. So the standard deviation was 7. That is our theta. Our standard deviation was 7. So our standard deviation was 7. Good. Now we want to draw the normal distribution. Now we have gotten the information that we need. We only need the mean and the standard deviation. So if I'm drawing my normal distribution graph, right? So this is it. Then I know normal distribution is always like this. So I'll draw it. This is my normal distribution, right? Let me shift this a bit upwards. Okay, now it is okay. Then I know that my mean is going to divide it equally into 2. That is going to be my mean. So my mean here is going to be 75. It's going to be 75. So I draw in 75, right? Then my next values to the right is going to be me adding the standard deviation to the mean. Do you get it? So 7 plus the 75 is going to give us what? So we'll keep on adding the standard deviation to the mean when we are moving to the right side, right? Then we subtract the standard deviation from the mean when we are moving to the left. So our first recorded value here is going to be 82. 82. Then we add 7 to 82. If we add 7 to 82, what do you think we are going to get? That is going to give us what? 89. Do you get it? That is going to give us 89. Then when we add 7 to 89, what are we going to get? That is going to give us 96, right? So that is going to give us 96. So 96, okay, 96. Then when we add 7, again, we are going to get 104, right? So 7, 4 plus, that is 103. Okay, so we are going to get 103. Now, when we do same for this side, this time we are deducting. We are just deducting 7 from the mean. So 75 minus 7, that is going to give us 75 minus 5 is 70, minus 2 is going to give us 68, right? 68. Then we'll do another one that is going to give us 61, right? When we deduct. So you can see that as we are moving to the left, we are deducting the standard deviation from the mean, right? So this is 60 minus 6, that gives us 54, right? So now here we are going to have 54, right? Now let's deal with this. So always remember, what did we say in the previous value? If we were to check this, if we come down, we learned that always the first values, the area between them is what? Forever and ever, it will be 0.6827. Do you get it? That is that if in case they are to ask us that what is the probability that a student will score 68 between 68 and 82? Do you get it? 68 and 82 are the first values. They are the first immediate values, right? If they are the first immediate values, then it means that the area under this particular region, the area under this particular region, because they are the first immediate value, it is also going to be what? It's also going to be 0 point. That probability is going to be 0 point. That probability is also going to be 0.68 then 27. Do you get it? Because they are the immediate values towards to the right, 1, and also to the left. Do you get it? And when we come to the immediate 2 steps away, we learn that from 2 steps away, meaning from here to here, 2 steps away from the mean, 1, 2. So if they are to ask us that what is the value between those who score 61 and 89, then we know that from what we learned earlier, if it is 2 steps away, then it's supposed to be what? 0.9545. Do you understand? So it doesn't matter what values are here. The concept is if it is 2 steps away, then it will always be 0.9545. I hope it is clear. Good. Now, that was what I wanted you to understand, right? Now that you understand, now let's come to the GeoGebra. When we come to the GeoGebra, from our question, let's go to back to our question, right? The question says that 800 students, mean is 75, standard deviation is 7. So when we come here, all that we are going to do is that the mean, we change it to 75. When you key in, you press enter. Then standard deviation is what? Is 7. Enter. Did you get it? It's 7. Then we still continue, right? So now let's continue. The question. Now we continue by using it to solve the question, right? Good. So let's come here. Let's come here. It says that what percentage of the class has a test score between 68 and 82, right? So what percentage? Let's go to the board. What percentage have a test score between what 68 and what 82? Between 68 and what 82? Do you get it? You see that we've already done that. Since this is 1 step from here, and this is also 1 step from here, we've agreed that when they are 1 step away from the mean, the region between them is going to be what? Is going to be 68, right? 68.27. Do you get it? So the question is saying that what percentage? We know that the probability is going to be 0.68. So what percentage means that 0.0. The 6, sorry, pardon me with my board. Okay, 0.6827. Okay, multiplied, when we multiply this by 100, when we multiply this by 100, then we are going to get, what are we going to get? The answer. What we are going to get becomes the answer. Then we know that when we multiply this, we are going to get 68, 68, 68, 68.27%. Do you see that? That will be the percentage of those who are going to score from 68, between 68 towards 82, or from 68 to 82. Do you get it? So now let's go back to, sorry. Let's go back. So what percentage of the class has a test score between 68 and 82? And that is going to be what? The answer that we just wrote, that is 68 point what? 68.27%. Do you get it? When we come to this, all that we have to do is that between what? Between 60, 68 and what? And 82, right? The key in enter. You can see that we have 60, 0.6827. They get it exactly like what we did on the board. But this is the probability. They are looking for the percentage. So we multiply the decimal by 100. Remember that whenever you want to change a decimal, a fraction to a percentage, you multiply it by 100. So we will multiply this by 100. We are going to get 68.27%. Do you get it? Good. So that is to say that we've been able to solve the first question. The second question says that approximately how many students have a test score between 61 and 89, right? Between 61 and 89. When we come to the board between 61, do you get it? Then what we drew, the diagram we drew, you see that it is coinciding with the word. It is not, the values here are the same as the values in the question, right? That means that we drew it well. So the how I was able to draw it, how I drew it from the beginning, right? Always follow that. When you are moving to your right, we keep on adding the standard deviation to the mean. When we are moving to our left, we subtract the standard deviation from our mean. As simple as that. So we know that between 61 and 89, 61 is what? Two steps away from the mean, and 89 is also two steps away from the what? From the mean. Do you get it? Good. And what did we say will be the probability when that is happening? We learned that if they are two steps away, then their probability will forever and always be equal to what? 0.9545. You remember? We said it here. If it is two steps away, then it's going to be 0.9545. It will be forever and ever, regardless of the values here. Do you get it? Good. So the question is asking that approximately how many students, to get it? Approximately how many students? We know that from 61 to 89, we understand that from 61 to 89, since they are both two steps away from the mean, one is to the left, one is to the right, we know that the probability is going to be 0.95, right? 95, then 45. Okay, so if we want to find the percentage of people, what do we do? This is the probability. But the question is saying by how many students? The question wants students. So we just have to multiply this by what? By 100 to get the percentage of students. I hope it is clear. So to get the percentage of students, and that is going to give us 95. That is going to give us 95.45%. 95 point what? So that is going to give us 95.45%. That will be the percentage of students that had marks from 61 to 89. But are we looking for the percentage? No, we are not looking for the percentage. We are looking for the number of students. So if we are looking for the number of students, then it's going to be the percentage of students, right? The percentage of the students, which is 95.45. So percentage divided by 100, right? Divided by 100, then we multiply by the total number of students, right? You remember that from the question, the total number of students was what? 800 students. Do you get it? 800 students. So that is to say that you multiply the probability by the total number of students, right? So let me pick my calculator over here. And to pick my calculator here, we have that mm, we have, so I'm inputting the question on the calculator. So 95.45 divided by 100 times the total, which is 800, to get it. So if you are to check here, you have to check here, it's going to give you the answer. And the answer is 763.6, 763.6. But the question is saying that approximately how many students, right? Approximately how many students. So if it is saying that approximately how many students, then it's going to be what? 764. That is when we approximate it to the nearest whole number. So 764 students had values from 61 to 89. I hope that is clear. So when we come to the GeoGebra app, right, all that we are going to do is from 61 to 89. Then we know that from 61 to 89 to 95.45. That is the probability. Do you get it? So the probability, when we change it to percentage like we did on the board, it is going to be 95.45. Then 94.45 out of 100 times the total number of students, right? So the 95.45 out of 100 is the same as the probability. That is by, so all that we are doing is that we are multiplying the probability by the total number of students. And that is going to give us the approximate number of students that had values from 61 to 89. I hope it is clear. Good. Now, let's go to our next question. It says that what is the probability that a student chosen at random has a test score between 54 and 75, right? Between 54 and 75. Then let's come to the GeoGebra. Between 54 and what? And 75. And 75. That is now 54 and 75. That is 49 point what? 97. So let me come to the question to see between 54 and 75, right? Okay, between 54 and 75. Now let's go to our board. Another thing that I want you to take note of is that now it is saying that between 54, right? So between 54, this is 54, and 75, that is the mean. So we want to find the distance here. We want to find the distance here. Do you see that? The distance here. Let me use arrowheads. When we shade that region, we want to find the area of the distance there. Do you get it? Okay. So then how do we do it? Coming to GeoGebra, all that we have to do is just to input the value. Then we are going to get 0.4987. So how many percentage, what is the percentage of students who had 54 to 75? Then it's going to be 0.4987 multiplied by 100, and that is going to give us 49.87. I hope that is clear. Good. Now let's go to the next question, right? Let's go to the next question. Let's go to the next question. Approximately how many students have a test score greater than or equal to 96? Right? Greater than or equal to 96. Okay, so let's see something here. If you want to calculate this, the third question, 54 and 75, if you want to calculate it manually, right? Then we already know that if we can calculate from this side, right, to this side. That is, this side to this side is 3 steps away. Do you get it? 3 steps away. Then whenever we are doing 3 steps away, we have a standard answer for it. The way we have 2 steps away, we know that 2 steps away is what? 95.45, right, percent. We know that one step away is what? 68.27%. So we have also an answer for three steps away. Do you get it? So when we calculate for the three steps away, we know that it will be from here to here. Then we can deduct, we can do subtraction from this region out to this region. We can deduct it from it. Okay, we can deduct this region from it. Okay, we can deduct this region. If we deduct this region from it, then it means it is going to be left with the region that we need. Do you get it? The region that we need. And that becomes the answer to uh, the normal distribution from 54 to 75, right? When we are doing it, we are computing it manually, right? Do you get it? Okay. Somebody might ask, then how then do we calculate this side to that side? To calculate for this side and that side, let me explain something to you. So to calculate for this side and that side, we can also do that, right? It is not difficult. So we can let me draw a normal distribution to explain something to you so that those who are doing it know just by hand, they will know what to do, right? So let's say that we are having our mean. Let's say this is our mean. Let's say this is our standard deviation, the first value that we recorded. We call it theta. So theta, the second value we recorded, we call it 2 theta. Do you get? We call it 2 theta. Okay, so 2 theta. But then when we come here, the first value we recorded to our left is negative theta, right? Then the second value to our left too is, let's say, negative 2 theta. So negative 2 theta. Okay, good. Now, what do I want to explain to you? What I want to explain to you is that we know we've all accepted or we've learned so far so good that the distance from the values that are immediately one step from the mean, both left and right, we know that this will always and forever be what? 68, right? 68. So let me ask you a question. If the region here is 68, then what does it mean? It means we can calculate for only this region to this region, right? Then we can also calculate for only this region to this region. Do you get it? How do we know that? By dividing the 68 into 2. If we divide the 68 into 2, then we are going to get what? Division. Point on your calculator, 68 divided by 2. So it means that this 68, if we divide it by 2, the answer that we are going to get will be the value for this side, then will also be the value for what? That side. Do you get it? Good. Then what if we want to know the value also for this side and this side? What do we do? To know the value from this side to that side, this is what you do. Now we know that the distance from here to here is what? 68.27, right? And the distance from here, the distance from the two steps away, the distance from the two steps away is what? 95, 95 point what? 0.45%. Do you get it? 0.45%. So if you want to know the region from here to here, all that you have to do is that subtract the 68.27, subtract 68. So 68 point, so 68.27%. If you subtract it, then the answer that you are going to get, right? The answer that you are going to get, you divide it by 2. If you divide it by 2, that will give you the answer that we are going to get. That will give you the values for what? Only this region. Let me use a different color. That will give you the values for only this region. From here to here, and here to here is the same as here to here. Do you get it? That means that we can calculate for the individual values of each region. Do you get it? If let's say there was to be another one, that is 3 theta here. If there was to be another one here, 3 theta here, do you get it? 3 theta here, and there was to be another one too, negative 3 theta, negative 3 theta. Okay, then I want to know only the region here. Then I want to know only the region here. That is, I want to know only the region here, only the region here. And I know that only the region here is the same as what? Only the region here too. They are all the same thing. Do you get it? How do I know that? To know that, you have to first of all know. the probability of getting three steps away from the left and from the right, right? And the probability of getting three steps away, when we come to the GeoGebra, the probability of getting three steps away. Okay, so three steps away from the question. Let's come to the question. Three steps away is 54 and 96. Okay, that is three steps away. So 54, that is going to be 54 and 96. And 96. That is it. So three steps away will forever and ever be 99.73. Okay? Three steps away. That is to say that from here to here, three steps away, from here up to here, the way we know that by default, two steps away it is 95.45. One step away is 68.27. The same way, three steps away is what? 99, 99, 99, 99.73, right? 99.73. Good. 0.73. So 0.73. So if I want to know only the regions here, what do? I subtract the second from here to here. I subtract from, you see that the reason why I'm subtracting from here to here is that I'm taking it off. So imagine that the distance from -2 to 2 theta is the distance from what? Two steps away. And the distance from two steps away is what? The 95.45. So imagine we are removing this. If we remove this off, then it is going to be left with this region plus this region. We want to know what they are individually are. So we divide by what? 2. Do you understand? So if I want to know only this region, then I'm going to do 99.73. 99.73. 99.73. So 99.73, right? Minus the region from the two steps away. So the regions from the two steps away is more like you are taking that space. Imagine that we are taking this space off. Imagine. Because that is the region under the curve from -2 theta to 2 theta, two steps away. Then we know that that region is what? 95.45. So we are taking that region off. 95.45, right? So 0.45. And if we are to take that region off, you can see from our diagram that what will be left will be this region added to this region all together. That'll be what will be left. So it means that when we divide it by 2, the answer that we are going to get will be the individual values from at this region and also at what? At this region. Do you get it? Good. Why am I doing this? That is to help you. So to help you, meaning we can individually, right? We can calculate for the regions here individually. Individually. We can also calculate for the regions here individually. You get it? Then we can calculate for the regions here individually. After knowing the regions there, when we add it together, right? When we add it together and we subtract from what we are going to get from the 54 to 96, that is three steps away. And three steps away is 99.73. Then we calculate this individually. Then we subtract the individually from the three steps away. It is going to give us the probability from here up to here. I believe it is clear. That is when we are doing it manually with pen and paper to get it. Good. But when it comes to GeoGebra will just give us the answer from 54 to 75, right? From 54 to 75, we are going to get 0.4987. And when we convert it to percentage, it's by multiplying by 100. So we get 49.87%. Do you get it? Good. Then the last question is approximately how many students have a test score greater than or equal to 96, right? So greater than or equal to 96, when we come here, we choose this option, right? You see that it is less than sign, but when we are reading it, we read it as x is greater or equal to opposite the sign. Then it says that greater or equal to what? 96. You get it? And the answer is what? 0.013. Do you get it? So if we change this to percentage, we multiply by 100, then the answer is going to 0.13%. I hope it is clear. But by how many students, right? By how many students is just by multiplying the probability by the total number of students. And the total number of students is 800 students, right? So 0.013 multiplied by 800. So let's do that on the calculator. Multiply by 800. That is going to give us what? 104. You get it? So 104 students had values or had scores greater or equal to what? 96%. I hope you enjoyed today's class. Let me wrap up, then we call it a day, right? So what did we do today? So let me do the quick note. Today we solved this question, but before we solve the question, we did some quick discussions, right? First of all, we discussed what normal distribution is all about. Then we got to know that for normal distribution, we have to know two main guys. The two main guys we have to know is first our mean, second our standard deviation. Then we learned that when we are drawing a normal distribution graph or curve, whenever we are drawing it, as we are moving to the right, we keep on adding the standard deviation to the mean. If we are moving to the left, we keep on deducting the standard deviation from the mean, right? Then we learned that we have standard values, as in from the first step to the second step. It will forever be the region from the first step to the left to the first step to your right. That particular region will forever and ever be what? 0.6827. That is the probability. First step away, both left and right, will forever and ever be 68.27. Always keep this in mind. Then when it is two steps away, right? Two steps away. So that's it, when it is two steps away. Let's say we drew another one, then we call this side 2 theta. We call this side 2 theta. Then we drew another one here. Then we call this side negative 2 theta. Negative 2 theta. So negative 2 theta, you can see that from from the region under the graph, from here to here, is what? Two steps away. Do you get it? It's two steps away. And when it is two steps away, both from the mean to the left and to the right, the region under there, under the graph, right? Good. It's forever and ever going to be 0.9545. Do you get it? Good. And when it is three steps away, then the region will forever and ever be what? 99 points. So we wrote it here. So let's go up here. Will forever and ever be what? 99.73. That is the value here. Do you get it? Good. So that is what we learned today, and we used it to solve the question. I hope you enjoyed this video. If there is any question or there are any questions, right, drop it in the comment section, right? Drop it in the comment section. We will attend to that as soon as possible, right? Good. So I believe this is the end of the journey for us. Keep following, keep liking, and keep subscribing. Have a lovely morning, evening, afternoon, depending on where you are. Bye bye.